Our students, here are topic 2.14, moving in circles. And here we are going to understand how things rotate, what is circular motions, and what force is responsible for that objects they can move or they can rotate in circular motions. What forces are responsible? Now, children, to understand this topic that I want to show you, I have tied a one marker on with this string, means with a thread. And I don't find any suitable object in my house, that any spherical object I was looking, but there was nothing. So any spherical object. So, and I'm trying to rotate it. Now, this is rotating in a circular path, if you are able to see on the screen. Now here, what happens, children? In the circular motion, if you see that this kind of rotation, this marker that the object is rotating in a horizontal, on a horizontal direction along the x direction. You can also rotate the same pen along the y directions by like this, along the y direction in the y plane. So whether it is the x, the horizontal plane, or the y plane. Now in these situations, what happening here, and who is responsible that this object marker is able to rotate in a circular path? That's the same diagram, the same thing you can find here on the screen on the left hand side. This one, this is the same thing. They said here there is a string that someone means here I am pulling, means I'm trying, I'm exerting a force on the thread, and due to that force this object is able to rotate. I'm applying a force with the help of my hand, with my wrist, and trying to make the object keep rotating in a circular path. What is the direction of that force? Now look at this diagram, children. In a circular motions, what happens, children? There is a force acting between the object and the string. This is the string. And this force is acting always toward the center, always towards the center of the object. And the name given to this force, it's not about force. The name given to this force is called the centripetal force. Centripetal force. So this is the force which is responsible for any object to rotate in a circular motions about any other object. And this force, that is the centripetal force, is provided by different kinds of means that we are going to discuss one by one. Who will provide this centripetal force? We are going to discuss. In this case, when I am trying to rotate the marker in a circular path, there is a centripetal force which is acting where? Towards the center of the circle. You know, the center of the circle means center of the circle. Who has provided it? Me. I am the responsible to provide the centripetal force, which acts where? Between object and the string. In what direction? Towards the center of the circle. For example, children. Now, children, remember, whenever the object is in a circular motion, so let me draw a circle here, whether it is a clockwise direction or an anti-clockwise direction, it doesn't matter, clockwise or anti-clockwise. This is the center. Suppose at any instant of time, object is here at point A. At point A. Now what happens, children, here? At point A, what will be the direction of force? As I said you earlier, there will be a centripetal force which acts toward this center. So you need to draw this arrow to represent that this is the centripetal force acting toward the center. If the object is, after some time, the object will reach to the point B, where is the direction of the force, children? Again, the direction of the force will be toward the center. If the object after some time reach to the point C, at this point, if we have to draw the direction of force, again, force always act towards the center. And similarly, when the object reach to the D position, and that the direction of force is still toward this center. This force which is acting toward the center, that is called the centripetal force. Centripetal force. Now here, one more thing, children. This force, that is the centripetal force, is always perpendicular to what? Perpendicular to the motion of the object. To the motion of the object. Listen carefully, to the motion of the object. Now, when the object is at a point, what is the motion of the object? Means actually that they are talking about to the direction of the motion of the object. Whenever the object is at point A, its direction will be, it tried to go in the straight path. You have to draw a tangent line. I hope you are aware about the tangent. A tangent line that passing to a tangent can be drawn on a curve, on an arc that touch only the one point. So if I draw an arc here, children, this is an arc, and if I say draw a tangent, so how would you draw? A tangent line will be just passing it. This is called the tangent line. So in a circular path, children, the motion and direction, it always change. Whenever the object is at point A, it is going towards the negative x-axis. You can see that it is going to the left side. But when the same object reach at point B, what is the direction of motion? At this point, the direction of motion will be downward. Tangent line you have to draw, and this will be along this direction. Means here I can represent the velocity, which is a vector quantity at point A. This will be along this direction, you can see. At point B, that the velocity direction of B will be downward. Whenever the object is at point C, that the motion or direction of the object, it will be, again, you need to draw a tangent, and this will be VC. Similarly, you can draw at the D point also. Motion is always, object always try to go away. Now, children, see here again, look at me. If I rotate this marker and if I rotate it, and if I release it, suddenly that the string break, what happens? I'm going to release it, and I will release it carefully so that it cannot strike with my laptop screen. And if I release it, so when I release here, what happens with the object? At the moment when I release, so it starts moving in a straight path. It moves in a straight path. It's not going to the circular path. It's not moving in a spin. It go in a one particular path. If object is broken, means if the string is broken at point A, my dear children, listen. If the string broken at point A, then the object will go in a straight path. It will follow a straight path. But there is a force act on this object, that is called the centripetal force, that makes the object to move in a circular path. This is according to the Newton's first law, children. Recall Newton's first law, what Newton has explained in his first law. In the absence of force, object constantly move in a straight path. Here, object is changing its direction continually. Object is changing its directions. Every time object is changing its direction in a circular motions. And we know that object change directions if there is a force. It means there is a force acting when the object move in a circular path. And the name given to that force is centripetal force. Now, let's look to the second example, children. In case of our solar system, what happens in our solar system? Okay, before going to the equation of, before taking the example of solar system, let me just include some other important point about the centripetal force. Centripetal force is given by, there is a mathematical equation, children, you remember, even though it's not required in grade 9, 10, mv square upon r. mv square divided by r. This is a mathematical equation for the centripetal force. You may note it down, children. mv square divided by r. What is m here? Mass of the moving object. What is v? Velocity of the moving object. What is r? Radius of that path, circular path. So mv square and r, please remember on this fact. Now here we have examples I was talking about. In case of our solar system, we know Earth rotates and revolve around the sun. Why it rotates? What happens if it stops rotating?
We will all be flung towards west.
Now, in case of our solar system, we know all the planets, they revolve around the sun in elliptical orbits, in some orbits. And if they're revolving in a circular path, we know, or in a elliptical orbit, so there will be a force. And we know that the name given to that force is called the centripetal force. But who provide that centripetal force in case of a sun and earth? Who provide? That is the force of gravity. That is called the gravitational force.
Gravitational exertion from the sun. Oh, I was just saying gravity from the sun.
Yeah, gravitational force in case of sun and earth, in case of earth and moon, in case of sun and moon, these all objects, all planets, they revolve due to the force, centripetal force, and the centripetal force here, you can replace the centripetal force, that this arises, the centripetal force arises due to the gravitational force acting between sun and earth and moon, and between any two objects in this universe which are revolving around each other. What about if you look at the example of, in case of, move to the atomic scales. Here we are talking about the celestial bodies, heavenly bodies, objects are of huge size. Come to the microscopic level, micro, children, micro, that the objects you can't see. Example, atoms. In atoms, we know that nucleus is there. Inside nucleus, protons are there, neutrons are there, and electrons revolve. Electrons are revolving. Centripetal force is there. Facts cannot be, you cannot ignore. Centripetal force is there. But who provides that centripetal force? In the small nucleus, inside an atom, who provides that centripetal force? Children. Who provide?
What?
In case of sun and earth, that the gravitational force between sun and earth. In case of when I was rotating the object in a circle, I am the factor responsible to make the object motion to be possible.
Is it the opposite charges between the nucleus and electrons?
Yes. These are the two opposite charges, that the electron and proton. And what happens in that case, the name given, you look here, planets, where is the electrons around the nucleus? Electrostatic force or the electric force. What is this electrostatic force? These are the forces which acts between the two opposite charges. We are going to discuss next year in grade 10, children. What is this electrostatic forces? So that is the electrostatic force and electric force, which is responsible to make the motion of electrons to revolve around the nucleus. Otherwise, electron will try to move outward in a tangent path. There must be a force. There must be a force to keep electrons to move in a circular path. So that is something about, children, in the circular motions. One thing you have to remember again, let me repeat. This force is always perpendicular to the motion. it is always towards to the center. Okay, if you talk in terms of acceleration, children, whatever the direction of force, that will be the direction of acceleration also. Sometimes we find questions, what is the direction of acceleration? In the same previous diagram, if I ask you draw here the circle on the left hand side, if I say draw the direction of acceleration, so acceleration you draw in the direction of force, and here the force is acting toward the center. Now, one last example, children. Look at this picture, children. That this man riding this bike, and when we take a sharp turn, that is again a circular motion, a sharp turn. Who? Definitely there will be a force, that is the centripetal force, which make us to take a turn. Otherwise, Newton said, if there is no force, you can't take a turn, and you may fall into to the other side of the road. You may go into other direction. You can't take a turn. Now here, the centripetal force is there. Who is providing that centripetal force in the case of this example? A biker riding a motorbike. The centripetal force here is provided by the force of friction, which is acting between the surface, between the road and the wheels of the motorbike. There will be a force of friction. If you remove frictional force, you can't take a turn. You will slip, and you will strike with some other side with the other objects. To always take a turn, children, force of friction. That's why high costly bike, you know, that the bike which are used in racing events, their wheels. Look at their wheels, children. Then you will find the wheels are such a way, they are designed in such a way so that they can keep its means it can stick with the ground, so that more and more friction force will be there, and that these drivers avoid slipping. So more frictions, more easily they can take a turn. So children, this was something about the circular motions, and now on Friday we have another class. On Friday we are going to discuss some questions, worksheet questions, and there is also your test. So after the test, we will discuss questions. Now I want to take one of the questions that is asked, question number 1 from the worksheet, children.